In this video, we're going to take a look at putting money in a bank or savings accounts and how that money makes money for you and the concept of interest and saving money and the difference between, putting money in a bank or getting allowances or set or simple interest equations. So let's take a look. Show me the money. And there is a difference between putting money in a bank and also getting an allowance is kind of the way I usually think of this. When you put your money in a bank, the money that you're earning is percentage based. Like they'll give you 2% interest or 4% or something like that. And therefore the amount varies based on the money in the bank. So you're going to get a varied growth because it's percentage based. Every time you take a percentage multiplier on something, that's going to change. The more money you have in the bank, the higher return you're going to get on your investment. The model for the equations become exponential. They're exponential change because eventually you're going to have money on top of your money and it's going to curve up, and you're going to have an equation where it's y equals a times b to the x, a being your initial value, what you invest in the bank, and b being your multiplier, the amount of interest that you're earning. Plus the 100%. You're going to have a 1.0 number here, a number greater than 1 to show that you're going to get that growth. Then it's compounded interest, meaning you get money on top of that money. And so it could be compounded annually, once a year, compounded semi-annually, 2 times per year, quarterly, 4 times per year, and monthly, 12 times per year. So once, twice, 4 times, and 12 times per year. This is going to come in important when we calculate the equations, because if you keep money in the bank for 1 year and it's compounded monthly, then you have to have an exponent of 12 to make that 1 year calculation. So these numbers are going to come in important when we make our calculations. Over on the linear side, or kind of like you can think of it as an allowance side, it's constant change. You go up by the same amount each week or each month or each year, whatever it is. It's a set steady rate. Well, set steady rates are linear. That's linear change. It's along the lines of y equals mx plus b. B would be the initial value, the money that you put in the bank. I put in $20, put in $100, whatever, and then your slope or your m is what it's going by. So if you can think of a situation where your parents give you, 10 bucks a week, well, that would be your m, 10 bucks a week. If you started with, $100 in the bank and they gave you 10 bucks a week, you could, have 10x plus 100 as your equation, and that's called simple interest when it grows linearly. It's a set amount. It's a straight, amount that you're getting in there every week, and it's kind of boring because it's linear, and there isn't a lot of situations where you have a lot of things going with simple interest, but it's a calculation that you need to understand. Most of what we're going to be working on is percentage-based stuff, and it is y equals a times b to the x. So let's take a look at a situation. So the first case would be, what if you were given this? So the first case being a situation where you have 2 tables and you're trying to figure out how your money is growing and what the equations would be for these situations. So as I look at these, you need to think about how the table is growing. Well, here, take a look. What is that doing versus what is this doing? A clue should be in how the numbers are changing, that if you have whole numbers to begin with and all of a sudden you get some decimals, well, then that has to be multiplying. It can't be adding the same number, because if it was adding the same number over and over and over, then it would not all of a sudden create decimals. Those decimals would have had to been created somewhere in here, right away for that all of a sudden decimals. So it's not adding. You can tell that this one is multiplying by some number. This one here is 20 bucks, 20 bucks, 20 bucks, 20 bucks. So we're adding $20 each time, which is pretty easy to see. Therefore, we can tell that this is the linear one. This is going to be simple interest. And simple interest is linear. So as soon as I get that, then I can say, okay, here's what it starts at, here's what it goes by, and those are the 2 things that I need. So what it starts at is 100, what it goes by is 20, it adds $20, and I put time up here because it could be per week, per month, per year, whatever, and in this case it would be times x. So our equation is just simply y equals, it starts at 100 and I add 20 bucks a week. Now again, this is one of those situations where you now have the variable term second. I mean, most mathematicians will just call this 20x plus 100, but either one of these model the situation that we're talking about here, where you originally had $100 in the bank and you added 20 a week or something like that. If you take a look over here on the compound interest side, so this is compound interest. On this compound interest side, we need to calculate what this thing is going by. We can clearly see we start at 100, just like we did on the other one. Okay, our initial value, our starting value is really important. I know that this thing starts at 100. So I know right away I'm going to have 100 in my equation. The zero value is always key. The next thing I need to do is figure out what this is going by. Well, it looks like it's adding 20. Oh, then it adds 24. Well, now it adds, 28 or, 2880. That's a little different. So now I've got to try to figure out what this thing is doing. So as it's going along here, that is when we build on the whole next divided by previous idea. I take my next number divided by the one before it, next divided by previous. So if I punch it in my calculator, you do need to check a few of these. So if I go 120 divided by 100, I get 1.2. If I do 144 divided by 120, that's the next one divided by the previous. And as you can see, I'm getting 1.2, 1.2. Well, I need to have an understanding of what 1.2 really means. It doesn't mean it's growing 1.2%. Okay, 1 is one whole. One whole stands for 100%. 0.2, if I have 0.2 as a decimal, if I want to turn that into a percentage, I move it back 2 places, that's 20%. So what this is showing me, if I think about this, it's like 120% growth. Well, that's 100% of my money plus 20% of my money. The multiplier is 1.2, and it's representing 120% that it's growing every time. Well, then your interest is 20%. So in this bank, they're giving you 20% interest. In this situation, you're just gaining $20 each time. So gaining $20 each time is going to be this. Now this is just showing an understanding that you know what a decimal stands for when you have a 1.2 multiplier. That's really a 20% increase. Now let's think about the number that goes in the equation. Well, the 1.2 is what it goes by. That's the number that goes in the equation, so 1.2. And then, to the x power, because it's repeated multiplication. And the definition of repeated multiplication is exponential. And therefore, the equation for this situation would be 100 times 1.2 to the x. And that's showing a 20% growth with that 1.2 number. All right, let's take a look at a situation where we don't know what's going on. We want to make a comparison. Well, case 2, a bank offers you one of two things. You can either take 8% annual interest, or you can take 8% APR compounded quarterly. Basically, what 8% annual interest means is that they're going to give you the interest, they're going to compound it, they're going to calculate it once per year. So if you think about a calendar going from January to December, and that's a whole year, they're going to give you 8%, and they're going to give it to you once. So every December 31st, they're going to make a calculation and tell you what you're going to get, another 8%, and then another 8%, and another 8%. So whatever you start with, let's say you start with $100 in the bank, and you're going to compound it in, annually. Well, they're going to give you 8%, so that's 1.08, and it would be to the x power. So there's your equation. Now again, the 1.08 comes from the fact that you had 100% of your money in there, plus an extra 8%. That's 108% of your money. Move that back 2 places to turn it into a decimal. It's 1.08 multiplier. So you can see you're going to get that money once a year, 8%. This would be your equation. Okay, let's take a look at APR compounded quarterly. Well, APR is just annual percentage rate. That's just the name for the percentage they're giving you. I could have put APR up in this example also. It's the same thing. But this says compounded quarterly. Well, if I make my calendar from January to December, they're going to give me 8%, but they're not going to give it to me just at the end of the year. They're giving it to me every quarter of a year. Quarters of a year, that means there's 4 of them. There's 4 quarters in a year, and they come at the end of March, the end of June, the end of September, and the end of December. So there is first quarter, second quarter, third quarter, 4 quarters in a year. 1, 2, 3, 4. And so I get my money compounded at each of these marks. Well, they're not going to do 8%, 8%, 8%, 8%, because then they'd be giving you 32%. So what you have to think about is how many times is it broken down? Well, it's broken down by 4. So I need to take my 8% divided by 4. So that's going to cut it into, they're going to give me 2% of my money here. They're going to give me 2% compounded here, 2% here, and 2% here. 2, 4, 6, 8. That's how you build this. So then that means if I have my original $100, it's going to get compounded or multiplied by 1.02 because they're giving me 2%. This is where you need to be careful. Yes, I understand the question has 8% in it, but they're compounding it quarterly or 4 times, so each time I'm compounding it's a quarter. And I like to put this up to the Q power, just so I remember that I'm counting the number of quarters. Q would stand for the number of quarters invested. So the number of times that I reach a quarter on a calendar, so number of quarters that I leave my investment in the bank. So then my equation would be y equals 100 times 1.02 to the Q. And so if I left it in there for a year and a half, I would do 100 times 1.02 to the 6th power, because a year and a half is 6 quarters long. If I left it in there for just 1 year, that would be 1.02 to the 4th power. And let's take a look at versus 100 times 1.08, and I put it in there for 1 year. So in 1 year's time, that's the same thing as 4 quarters, so this one would be 4 quarters long. This would be my numbers, and then the other one would be 1 year long for this first example here. And which would we pick? Well, if you compound, the more you compound, the better off it is for you. So if I take this 1.02 to the 4th power, compounded quarterly, at the end of the year I'd have $108.24. If I do it the other way, and I take it times 1.08 to the 1st power, leaving it in there for 1 year, because it's only compounded annually, I get $108. So the more you compound, the more times the bank compounds your money, the more you're earning. So just a quick snapshot of what it starts at, what it goes by, and if it's compounded in a broken down segment of a year, think about a calendar, think about how many times you'd break it up, and that's going to be your exponent or your power. You'll see 1 year is the power of 4. Here, because it's just annual interest, that's only once a year. So your X being the year, you only have a 1st power for a year. Okay, back up here, remember, simple interest looks linear, it's adding. It's going to be these equations that you're very used to, y equals mx plus b. If you figure out the multiplier using x divided by previous, you're going to come up with an equation like this for your investments. And then that is the differences between investing with percentages based numbers or just straight constant change. And that's what we're looking at here in chapter 3.